So good evening, everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects on making connections between proportional reasoning and fractional thinking with Kyle Pearce. We have a large group this evening with mostly experienced participants, and Kyle is also quite experienced with OTF Connect, so it should all go smoothly. And thank you all from all across the province for participating in the session tonight. As you can see, we have a lot of people from all over the province. Comme toujours, je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Cette session est entièrement en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à nous contacter par la suite. We're definitely thrilled to have each and every one of you with us tonight, and it's also our absolute pleasure to welcome Kyle Pearce. I had the pleasure to moderate for Kyle last season, and I told the story of one of our OTF director having a meeting with a couple of professors as well as the Dean of Education at MIT in Boston a few years ago. It's a rather cute story, and I would like to share it with you guys again this evening. So this is the way it went. In the course of that meeting at MIT, as my OTF colleague was making reference to Kyle's work without actually naming him, but she was just saying something like, one of our teachers, Kyle, has developed some interesting tools, blah, blah, blah. And to her surprise, the dean actually interrupted her to ask, do you actually mean Kyle Pearce? So she was really astounded that in the MIT Faculty of Education, they actually knew that if someone named Kyle was doing great things in Ontario, it might just be Kyle Pearce. So anyway, I think it's a cute story, and I hope that Kyle won't mind that I brought it up again. It certainly speaks volume about Kyle's international reputation in academic circles and about the quality of his work. At a more local level, Kyle is a mathematics consultant with the Greater Essex County District School Board, where he tries to uncover new and creative ways to spark students' curiosity using tasks that are visual and concrete. He shares his work by leading professional developments in both mathematics pedagogy and the effective use of technology. You can learn a lot more about Kyle by visiting his website, tapintoteensminds.com. I will post the link to that website in our chat box in a few seconds. Kyle has prepared a fantastic presentation for us tonight. After reviewing it last night, I got the strong feeling that he may have found the secret to the philosophical stone of mathematics and be able to actually turn 24 hours a day into 48, because I'm quite jealous to see how productive he is. So it's quite a presentation, you will see. We are all in for a treat tonight. So at this point, I will pass the microphone to Kyle and let him keep introducing himself as well as tonight's presentation. So Kyle, if you're ready, feel free to jump in anytime you want. Click on your talk button and go ahead.
Wow, that's excellent. Thank you so much for the excellent introduction there, Michel. I'm very excited about tonight's session, as I am for every session. However, this one in particular, I'm really excited about because we're going to dig into some ideas around proportional reasoning and fractional thinking. So that I'm really excited to dive in here. This is kind of new territory for myself, and I think for a lot of others as well, trying to look at making fractions a little more visual. So thanks again for the great introduction. I'm so excited to see such a great turnout of people in the room. So let's first get ourselves started. We'll do a little bit of housekeeping items. I had already mentioned that we do have a link for tonight. Anyone who's been in these sessions before, we definitely have Knowledge Hook game show in the background that's going to be running for some of the activities, just so that you can upload some solutions. So ultimately, I'm really using this tool in the webinars so that you have an opportunity to share some of your thinking. So if you don't already have some paper and a pencil, or maybe you have a tablet and you like writing on that, whatever you have, we're going to get you to do some of the math, and maybe even with some manipulatives if you have them around. And if you have a mobile device, it's a great idea to log in to playkh.com on your browser. Doesn't matter if it's an Android device or an iPhone or an iPad or a Windows machine, whatever it is. The main purpose is so that you'll be able to take a picture of your work, and I'll be able to display some of those up on the screen. So Michelle and I had a discussion earlier today about how we're going to try to make that happen, try to make this interactive, and really try to engage the participants instead of it being a pretty passive experience. So you can get yourself logged in there. When you go to the playkh.com website, you'll notice that it's going to ask you for a game pin. So we're going to have you put in Wiz623, and that'll be our room. I'm looking on my screen, I see about 13 people in already. No panic if you're not in yet. I will put this information back on the screen when we're about ready to start that game show. Once you're in, you'll notice it'll ask you for your name. You could put full name or, you know, a funny name. It doesn't really matter for tonight, but again, just hoping so we can share some solutions. So pick your avatar, and then you'll hit join, and it'll say you're in, and we'll wait for the game show to begin. So I won't start that game show until we get to that particular point in the slideshow. The key you're going to be looking for, though, is in order to share your solution. So once you input your solution or type in what it's asking you to type in, it'll give you a little modal that'll pop up and say, you know, congratulations or thanks for entering. You'll just hit close, and you'll notice a share your solution button up on your screen. That's where you'll be able to access your camera or your photos on your device, and you'll be able to upload it so that I'll be able to access it, and I'll insert it into the slide deck. So we'll try to get that going. We'll see. It's worked pretty well in the past, so hopefully we'll be able to continue that tradition here in our OTF Connects. So for those of you who are new, I thought I would take a little bit of time. I was the one with the arrow pointing at Windsor, Ontario. I'm just east of Windsor. We're about 3 exits away from Windsor on the 401 on Bell River, Ontario, which is on Lake St. Clair, which connects the Detroit River and St. Clair to Lake Huron and all the way around to Lake Erie. So we are situated there. This is my first year as the K-12 math consultant for my district, Greater Essex County District School Board. And I've got a couple certifications through Apple and Google that really have me thinking about how we can integrate tech into the classroom. So we'll try to do a little bit of that as well through the Knowledge Hook tool, and we'll dive into some fractional thinking and thinking proportionally. So I always like to begin these sessions kind of just coming back to this vision. I have this firm belief that, you know, the more I start to visualize math, the more I connect it to context that makes sense to me and to my students, and the more concrete I can make things, the better off the understanding is. And if we can try to connect that through the Ontario math curriculum, then I think we're going to be well on our way to start increasing that confidence, especially if you're in the intermediate. End of junior, intermediate is sort of where we lose a lot of students in terms of their excitement for mathematics. So a lot of times we have to build that confidence and regain that from our students, and really change their perceptions of what mathematics class is. So if we can make it visual, I really believe that the perceptions will start to change, and I think in the end we'll see achievement improve as well. So that's kind of the goal. That's my overall, my overarching philosophy moving forward. So what we're going to do is sort of backtrack to our last session, paying attention to proportional reasoning, and we're going to use that information in order to springboard us off into the paying attention to fractions document. You'll notice a quick link up on the screen, kylep.ca/PAT FRAC, And really, it's an easy Google search as well. If you just type in paying attention to fractions, it'll be the first link that pops up for you. What a great document that really tries to outline some of the key pieces for fractions. And I think we'd all agree that fractional thinking is something that students typically struggle with. And I say students, that includes us as the adults as well, because somewhere along the line, many of us sort of took the route of procedural and don't really have a full conceptual understanding. So I'm still trying to develop my own conceptual understanding as well. So if we open up that document, there's some great quotes in there, and really this particular quote suggests that explicit and precise changes to learning and teaching practices can have a substantial impact on children's understanding of fractions and future mathematical success. So those instructional decisions that have a significant bearing on students' ability to understand the concept of fractions, including the ability to represent fractions appropriately, compare the relative magnitude of two fractions, and complete calculations accurately. When I read this quote, you know, it really does outline how complex fractions really are. And I think, again, we'd all agree that many of our students struggle with at least some portion or some understanding of fractions. So that's what we'll be focusing on tonight. And as we move forward, we'll start talking about fractions and ratios as relational numbers. So if you recall, if you were in our last session, when we talk proportionally, we are talking about a relative, relating two numbers together. So it's like a relative thinking versus an absolute thinking. So now when we're talking about fractions, fractions really are created to service our understanding of proportionality and proportional reasoning. So we'll be looking at that, and in particular tonight, really some different ways that we can use fractions and how they're useful, and maybe even why they might be so confusing to so many of us. So when I go into this particular document, the paying attention to document, it's interesting because, you know, the simple definition is a fraction is a number, which I think is maybe a little bit too simple for us because there are some complex constructs that really lie within that big idea. So oftentimes we use fractional notation when we're comparing quantities or using quantities that are not whole. We have, like, you know, this understanding of a fraction can be more exact than using a decimal number in some cases. But really, I think the different ways that we can use fractions and the different constructs are what we can really start to struggle with. So as we move forward here, I'll give another quote. The essence of proportional reasoning from that paying attention to proportional reasoning document is the consideration of those the consideration of numbers in relative terms rather than absolute terms. So those of you who are with me will remember that we gave a couple of examples, but ultimately what we're doing is we're comparing two numbers. And when we use a fraction, we're comparing the numerator and denominator in some way. There's a common way that we typically think. We usually think in a part-to-whole relationship, but there's actually three other ways that we can use fractions, and oftentimes that could be why students find it so difficult and challenging. So when we go back to that proportional reasoning document, comparing an absolute versus a relative understanding of numbers, if I think of 8 as 2 4s or 4 2s rather than 1 more than 7, or if we think of speed as 50 kilometers an hour is the same as 25 kilometers for every 30 minutes, we're now thinking proportionally. So you'll notice there's some fractional thinking built in to our proportional reasoning. Now, when I was planning this session, I really had a bit of a struggle on my hands because I wanted to dig back, and I wanted to, it's sort of a chicken, you know, which came first, the chicken or the egg scenario. You know, is it proportional reasoning that comes first, or is it fractions? And I would argue that the idea of a fraction is really built to service the relational thinking that proportional reasoning provides us. So if we think of when students or kids actually start thinking proportionally and ultimately leading them down that path towards fractions, oftentimes this happens when they make comparisons. So for example, my daughter is 4 and she's in JK, and she can already make comparisons such as one bag is heavier than the other. She's not giving me a exact value, but she definitely can make those two comparisons. So one relative to the other, or I'm this much shorter than you are, or there's 5 more red candies than green if we start to actually look at quantities. So again, these early comparisons, my daughter will typically speak of them in absolute terms or additive terms, saying how many more, rather than that relative or that multiplicative thinking. So I believe this is where it begins, and then students, ultimately, we have to help them see that multiplicative or relative thinking actually exists and start shifting them in that direction when they head into grade 2 and they start using groups. So I think it's time for us to get to some of the math. I think I've done enough of talking here. So we're going to explore 4 common fraction constructs. And I think, again, I'll put up on the screen, if you're not already in the game show, we will use game show. I see 30 people in the room now, so that's awesome. So again, that link, playcage.com, and the game pin is Wiz623. And we're going to start with a situation. It's not going to be in the game show. This first one we're just going to do in the chat box because it doesn't really require any solutions, just kind of thinking here. I'll skip past these 2 here, and we're going to start looking at a couple of cartons of eggs. So on the screen, if I go to my next screen here and I open up these 2 cartons, the first question I have for you is just how many eggs are there? So you can just share that out in the chat box. How many eggs do you see there? And we'll put that right into the chat box. Ooh, I like Anik is thinking outside the box here. Well, I guess it's inside the box in this case, lame math joke, but doing some unitizing, showing 3 groups of 6, which equals 18. I like that thinking. Awesome, 12.5. I've got a lot of 18s. And Jamie's not seeing anything. That's not a good thing. I apologize, Jamie. I don't know if Michelle might be able to help you out in a chat box, in a private chat box there. We've got 2 rows of 9. I like that as well. So all kinds of different representations we have. Now, I mean, you can look at this as a closed question, meaning how many eggs are there? You know, count them up, 1-to-1 correspondence. Or some people can think a little bit outside the box and start grouping, using unitizing, and all of these pieces that we had discussed back with the proportional reasoning webinar. So I'm going to change the question slightly, and just in the chat box again, I'm going to ask you, how many cartons are there? How many cartons do you see? And maybe you see it in more than one way. So feel free if you want to put in more than one response. And it is, again, pretty open question. I see a few people are saying there are 2 cartons because physically there are 2 cartons. I might word this in a classroom. I might say, how many full cartons are there? Yes. Jay Lim is saying 2 cartons. I didn't ask about the eggs. Absolutely. I'm definitely expecting some to reply. At this point, I would typically have my students chat with each other. So what interpretation do you see? So we can change this thinking a little bit. And now I'm going to have you start thinking about this question. How many cartons are there related to, or let me reword it this way, how many eggs are there relative to how many cartons there are? So is there a way that we can reference the eggs, but also reference the cartons as well? Awesome. So I'm seeing a lot of 1.5. So I see an 18-to-2 ratio. Awesome. Which is more proportional and fractional thinking. I see 1 full carton and 1 half full, which is nice, keeping that context alive. Awesome, 1.5 to 2 I see. So lots and lots of different ways that we can view this here. So I'm just going to share with you here a couple screenshots, and I saw a few people saw 1.5. So if we think about that, you know, if a whole is defined as 1 carton, And a half, we have another half of a full carton. So we can see 1.5 in that particular case. If I was to reference it this way, I'm using a set model, but at the same time, I'm sort of incorporating a bit of an area model into this representation. So if I really look at it, this whole of 1 has the 12 eggs there, and it's actually taking up an area, a rectangular area as well. And you'll notice that the half take up half that rectangular area. We could look at it as a set because it's individual items as well. But there's also a representation that I don't, or personally didn't see a whole lot and maybe didn't use enough when I was using fractions in the classroom. But even just looking at it as a number line as well can be very, very useful for students to see. So lots of different representations. So you're going to notice that I'm going to be coming back to some of these things. And as a hint, I'm going to encourage when we do some of our questions and we upload our solutions, try a representation that maybe you're not so familiar with. Maybe a number line is something that you haven't used a whole lot. Maybe you have to do a little bit of deeper thinking, or an area model or set notation versus just our symbolic notation. All right, so that's that. Something we can also do with our number line, we did a little bit of this in our last session, is we can use a double number line in order to show that relationship. So when we think about that proportionality, I can show how many eggs there are to how many cartons. So I have 6 per 1/2 carton, I have 12 per 1 carton, 18 per 1.5 carton, and so on. Now, if I think about this a little bit differently, I had it split up into a whole being the carton and our halves. We can also think of the entire carton in halves. How is this going to change the representation? Before I had 1 and 1/2, or maybe 1.5. How does this visual change how I might represent the fraction? So feel free if you want to share it in the chat window. What might this represent for me? Awesome. So I'm seeing, and I'm going to type it in the chat window as well. I see some people who are saying 3 to 2 and others who are saying 3 out of 4. I'm going to go ahead and say that I think both of those could be correct. Can you verbalize it by typing in what the 3 and the 2 mean for that to represent this scenario, and what the 3 to 4 mean to represent this scenario? Because I believe both of those can work if we properly identify what each number represents. So I'll give you an opportunity to share out in the chat. Awesome. So Seema's saying 3 parts of a set of 4. Melissa's saying each whole has 2 equal parts. Interesting. Ooh, nice. So I see 4 groups of 6. That's another representation that could work here. So what I'm trying to pull from you, and it's working perfectly in this case, is how confusing fractions can really be without fully understanding what each value represents. So 3 to 2 could work, but it might be very, very wrong if I'm not thinking about what those 2 numbers mean relative to one another. So if I'm thinking about 3 to 2 here, I'm thinking of 2 parts being my whole. So there are 3 parts, and 2 parts represent a whole, meaning 1 carton. And if I have 3 out of 4, then that suggests to me that my whole is 2 cartons. And when that's totally legit. So it's not very typical, but that would definitely work as well if I define my whole as 2 cartons. Maybe it's a 2-for-1 sale and you got to buy 2 cartons. Who knows? So really, as long as the point we're trying to get at here is, as long as we define what those 2 values are, then we're in the clear. In the clear. And what I notice in classrooms, and it happens as we start using fractions more abstractly, when we start moving towards adding and subtracting fractions and manipulating with fractions, we start to lose the context in a lot of cases. Or a question in a textbook is contextual, but then we pull apart only the numbers and the values without really defining what those values are. So that can be very difficult for a lot of students. So for me, what I'm trying to pull here, assuming that the whole is 2 parts, I might represent on a number line like so. So that 3 out of 2 would be appropriate here, which is relative to 18 eggs. So some different representations. So you can see how students might struggle with this idea. And what we're defining here is what we call a part-whole relationship. So glad to hear there, Jessica, that you like the double number line. That's awesome. It's something that's fairly new to me as well. Something to Google if you like a lot of ideas with double number lines is called clothesline math. So like hanging up your clothes. Awesome math tasks associated there, not just for fractions, but all kinds of different mathematical representations. So ultimately, we're looking at a part-whole relationship where the numerator is a part of the denominator, which is the defined whole. So when we're thinking about that, that can be very confusing for students. And this is the one that I think most of us feel comfortable with, a certain amount out of a whole. And there are 3 other fractional constructs, though, that can be a little bit tricky. So let's move on to our next one. If you were with us last time, you're going to remember our hot or not situation with the Doritos roulette. Again, you can take that task and you can modify it and really get a lot of use out of it. If you recall, there is we called it the hot or not ratio when we were comparing how many hot chips there were to how many were not hot. So if we look at this representation, I'm wondering, can anyone share what they believe or how they can represent fractionally the hot to not relationship? So go ahead in the chat box, hot to not relationship. What do you think here? Oh, awesome. So it looks like some clothesline number lines. Oh, up on Twitter, awesome. From Moya, awesome. Interesting. So I'm seeing 2 representations here. So I'm seeing some folks are saying 1 to 6 using a colon to represent a ratio, and other people are saying 1 out of 7 with a fraction. So again, it really does come down to what it represents. So Jamie is saying there's 1 out of 7 that are hot and 6 out of 7 that are not. So again, that would be a valid representation, right? So it really depends in what we're referring to here. So 1 to 6, and I'm going to type it into the chat box just to make it really clear. 1 out of 6 and 1 out of 7 can work. They both can work. But specifically, if we're talking about hot comparatively to not, then we're dealing with 1 hot out of 6 not, which is, again, very difficult for students to wrap their head around. All right, so we're going to look at this a little bit further. So let's line these chips up here. So, looks like my word hot on that chip didn't work out so well for us. So I missed that. So if we look at what fraction of the chips to not hot chips are there, we're looking at 1 hot to 6 not. So that would be a valid representation. Again, not the only representation, but a valid if we're comparing the numerator to be hot and the denominator to be not hot. So there's for every 7 chips, 1 would be hot and 6 would be not. And if we look at that a little bit further, we can again use a number line. You'll notice that I'm representing this a little bit differently on the number line in this particular scenario, because again, we're not adding on the fractions here. We're just using the number line as a comparison in terms of magnitude. So this number line, really what it's representing is the true value of the numerator and the denominator. So when I look at 1 for my numerator, you'll notice that the not hot chips is 6 times longer. That arrow is 6 times longer. That number line is 6 times as big, right? So it's a bit of a different comparison. And again, that could be really, really a struggle to wrap our heads around. And when we reference fractions in this regard, we call this a part-to-part relationship. And it is totally valid to represent it as 1 for the numerator and 6 as the denominator. However, we typically represent it as a ratio, 1:6. And I'm going to argue that it's probably a good idea for us to reference them both ways so that students can get a little bit more fluent with these different representations and relationships. Awesome. Oh, okay, Melissa's sharing. Nice. So kids are starting to represent fractions like that. That's great. Awesome. So that's our part-to-part. So we've covered 2 of these constructs. And again, gets, pretty tricky stuff when we think about them. And in my head, thinking of it as a grade 9 math teacher for a number of years, I'm very, very familiar with a part-whole and a part-part relationship as something we use in proportional reasoning quite a bit. So this is something that might not be so familiar for teachers that are just getting into proportional reasoning pretty heavy in the junior grades. So hopefully that's helpful to clear up a couple of those ideas. So let's move on to our next scenario here, and I think it's going to be the first scenario that we're going to use our Knowledge Hook game shows for. And I'll put it up on the screen on Blackboard, but it should also come down to your device right about now. It should be showing up on your screen. And if you don't see it, you might just have to hit the refresh button. But basically what I'm asking you is, how can 4 friends share 6 brownies fairly? And really, what I'm really looking for is, can you in some way, shape, or form show your thinking on a piece of paper or digitally? And once you're ready, in Knowledge Hook, we'll have you select, I'm ready to share my thinking, and then hit the Upload Solution button in order to share your solution with us. You'll notice at the bottom of the screen, I have a little animation that's showing you how you can upload. So if you're struggling to see that, you should see those instructions showing up on the game show window. So I'll give you a little bit of time to do that, do some thinking, and then we'll get folks to snap some pictures through Game Show and upload some solutions, and I'll share them on the screen. I think I heard a hand up, so if anyone wants to chime in with their microphone, feel free to, but I don't see the hand anymore, so maybe that was hit by accident.
Sometimes people just raise their hand when they are done with an exercise. It's something that we do in a lot of our sessions. When people are done, they come back into the room and they raise their hand, so that might be that as well.
Awesome. Thanks for that. I was unfamiliar there. And I should mention to the group who's working on this problem now, feel free as well if you're having a hard time representing it, let's say with one of the suggestions, area model, number line, don't worry about that. You can do it completely symbolically if that's your comfort zone, or a unique way, anything you want. Really, this is just about trying new ideas. We're going to share some out, and then when solutions come in, I see a few have been uploaded as my children are screaming in the background, and we'll share some of them out, but I won't reveal any names. We'll just reference them anonymously as well. All right, I see 12 out of 33 in Game Show are locked in, so that's awesome. So we'll keep that going. At this point, if you're still finishing up your solution and you're not ready to upload a solution yet, that's completely fine. What I'll have you do is hit I'm ready to share, the button there, and then when I end the question, as long as you've hit a solution or an answer, the upload solution button will still be there. So as we're consolidating, you'll still be able to send another solution in. All right, but you do have to select one of the I'm ready to share my thinking or one of those survey options in order for that upload solution button to appear. Okay, so the first time, sometimes it's a little bit you know, of a learning curve there when you're trying it for the first time. Looks like it's freezing for Candace, which is unfortunate. My suggestion might be to maybe hit the refresh button, and then. Yeah, I don't know how I'll be able to help you there. Sometimes if I'm in the same room, I might be able to, you know, clear your history, your browsing data or something, and sometimes that'll help as well. But do your best to hang out with us, and hopefully we'll be able to get some of your solutions up as well. All right, we have some folks sharing out into the chat room. Diana, if you're trying to get in on your mobile device, you're going to go to playkh.com, just the website on your device. So there is an app, but you don't need the app for it. I usually just run it right from the browser, and the PIN is Wiz623. All right, I see quite a few people are in. So again, your last chance, if you do plan on uploading a solution, hit one of those buttons just so that you've locked in, and you'll have that button available to you. And I'll end it so that I can have a look at some solutions, and I'll try to upload them to the screen. And we'll try that out for the first time. Michelle and I are really being daredevils today because we've never tried this on the fly, but we'll give it a shot. So I'm going to go ahead and end the question. We'll take a look here. I see, I can see 5 solutions on my side. So I'm just going to go ahead and toss these on my desktop real fast. Cool stuff. I like what I see so far. Some creativity there. Oh, somebody's even doing a digital solution. You won't see them on your screen yet. I'm still trying to pull them to my desktop, and I'll put them in the browsing window in just a second. All right, perfect. So let's try to load some of this content in here, and let's try. Let's see what we get here. Okay. Well, look at that. What a beautiful thing here. If you look in your Blackboard window, if you can just give me a check mark if you can see the solution up on the screen. It looks like it's might be a whiteboard of some type, or maybe that's just pen. I'm not sure. But it looks kind of shiny, so I'll go with that. I see lots of green arrows. Awesome. So it looks like we've got our 6 brownies here, and it looks like you've decided to do a little bit of like halving in order to share out, which is pretty cool. Awesome to see. I like that. Way to show it. Let's look at the next one here. If I go to the next one, where am I here? There we are. So here's one. Ooh, this one looks pretty interesting. So someone's taken a digital screenshot, and if I had to guess, I know it's a little bit harder because we're not all in the same room. I would typically have you explain, but my guess is that you've handed out a whole brownie to each person, and then the last 2 brownies you've split fairly by having them, which is pretty cool. Awesome. And Amy, that's the best way to go for a student, right? You're like, I have 4 friends, but my mom and dad are pretty awesome, so I'm going to share the last 2 with them, and then everybody's happy. Here, this one's a little fuzzy, but it looks very similar to the last sharing where you shared 1 each and then halved. Seems like a pretty logical way to go. Ooh, interesting method here. So you've done. It's almost like I'd be curious to know if you, I think the photo might be upside down, so I apologize there as well. But it looks as though you've almost maybe spatially looked in order to get your 4 groups and determined how many brownies and how many halves are going to have to go into each one, which is awesome. And here we have kind of a symbolic, or I guess a verbal explanation as well, which is pretty cool stuff. So lots of awesome solutions here. So I almost feel like it's, silly for me to share out some of mine because you ultimately hit most of them, which is pretty cool. So I think the one that I don't think I saw, which is what I think we sort of encourage students to do quite a bit, is this idea of splitting each one 4 ways, right? Symbolically, this is what we end up doing in a lot of cases. So even though it doesn't really make sense in real life, it's what we do, or it's what we suggest to students to do in many cases, even though now we've just made a mess of all our brownies. So Anik have done the same thing as well. Yeah, so you think about it like in real life, it doesn't seem too logical, but it's what we sort of push in school quite a bit through this idea of just sort of chopping it all, taking your 6 brownies and dividing them up amongst 4 people, right? So it's simple division. And from there, we can divide them into quarters. And then we just split each quarter evenly across the group, and we end up with 6 1/4 pieces. So that would represent our improper fraction representation here. Another way we can do it, and we saw this one as well, was sharing 1 each, and then splitting or partitioning the remainder, and then splitting them up evenly that way. Oh, my 1/2s look pretty ugly on that photo. I apologize. So there they are there. And then finally, the last one does the same thing, accomplishes the same thing. Notice that the last one was a improper fraction, and this one represents the mixed fraction. So that's something that I think a lot of times we sort of forget to do is, we work with improper and proper fractions, but not through context. So it's very difficult for students to really understand how to go from one to the other because they haven't had the experience of seeing what those fractions represent visually. So if we look at this, this will give us the same 1 and 1/2, but this is again where we sort of take and we line them up and really try to divide them into 4 equal groups by making 4 or 3 cuts, I should say. And we end up with that situation, which we did see visually in the previous solutions from the participants. So again, a lot of different ways to represent the same situation. I thought I'd throw the number line in there as well. So here's a number line representation here to represent that last solution, but it could look a whole lot different, right? We could do it in halves, or we could even do it in quarters as well. So there's lots of different ways that we can represent using those number lines, and we call this using fractions as a quotient. So this is kind of our fair sharing or typical standard division. I have this many of something and I have to divide it into so many groups. So that's our 3rd fraction construct that we're going to look at this evening. All right, so let's see what we have here. Let's look at one more of these. We're going to do a Rollo situation, and we're going to talk about Rollos. I'm going to skip to the next slide here, and I'm going to ask you, and I'm going to mention right up front, if you've never had Rollos, the standard package has 7 pieces in every full roll of Rollo. All right, 7. Nice number to work with, especially when we're trying to do some fractions here. So here's your question. I'm going to send it down to you through Knowledge Hook. You might have to go ahead and do a refresh of your browser. I'm going to hit the next question button now. It should be up on your screen now. So hit the refresh button if it hasn't already come down to you. But you should see that same question. And again, I have the animation showing how you can upload your solution. So you do have to hit one of those answers before the upload solution button will appear. So we'll give you a little bit of time to work on this one. See if you can represent it in one way or more. If you can show it in more than one way, that would be awesome as well. And then we'll share some out. All right, and I'm also going to add in, I see most folks are seeing one full roll, which is awesome. Now I'm going to challenge you to think about how many pieces are there relative to each full roll. So trying to make that relationship between the 7 pieces and those full rolls. All right, we're starting to see some solutions coming in. So again, if you're interested in participating by sharing your solution, I'm going to have you just go ahead and hit one of the buttons there. I have an answer, but can't I am ready to upload. Even if you're not, I'll have you hit ready to upload. And once you do that, that will give you the opportunity to upload your solution when you're ready. So as I consolidate, I can end this question and I can pull the solutions, and you can add them as we go, and I can take a look at the first couple and then load in the others. So I'm going to go ahead and do that now. All right, so I see some solutions coming in here. So if you have a look at the blackboard, it looks like here we're using some symbolic notation. I'm not sure if it was first or not, but it's listed first. And it looks like a visual to help support there. So we've got our 5 dots, and it looks like our other 4 dots. And we end up with 9 out of 7 as a whole. So in this particular case, we are talking part whole again. But we're doing something a little bit different. Maybe some of you have picked up on it. I'm not sure. We'll talk about it in just a second. So great solution here. Let's take a look at another one here. Looks like a visual representation. It looks like our 5 up in a horizontal row, and then our 4. It looks like we've created a whole by circling 7 and leaving 2 on its own. So 1 whole and 2 sevens, or 9 out of 7. So 2 representations there. Awesome. Again, a visual and a symbolic. Great. And then in this particular case, it looks like we might have a bit of a misconception here, because 5 sevenths plus 4 sevenths is 9 out of 14. So just keeping in mind that the whole is still going to be 7, so we're going to maintain that whole as our solution, 9 out of 7. So that's something to keep in mind. That's super, super common. And here another visual, which is pretty cool. I like this idea of how many there are versus how many are not, showing the little lines there. And then we're filling up our Rollo, and we are left with 1 and 2/7 left over. Lots of great visuals going on here. Awesome stuff, my friends. Again, another great way to represent this as well. Looks like on your, is that a calendar there? Let's see, belief draft is due on the 2nd, so that's late if you haven't done your belief draft. Okay, just a heads up. And good luck on your law quiz. Yeah, I like that as well. Good stuff. All right, next one. Again, awesome visuals as well. We're showing symbolic here as well as a visual. Great stuff. And yet another as well. So lots and lots of great representations here. Due to the ability to use technology, I've got the ability to do some overlay here, so we can again see that 5 out of 7 plus 4 out of 7. We can look at it as just individual 7ths and add those guys up, and we end up with 9 pieces out of 7 pieces as a whole. Or we can even go on to the number line. If we squish these guys together and do a little bit of rearranging, we can see the 9/7 on the number line as well. Something we could also do, I don't think I did it, now that I'm going to have to add this in for the next time I do this, this presentation, but we could also indicate on a second number line the wholes. So here I have indicated the whole numbers as 1 and 2, but that might be better served on another number line, just so that students can sort of keep that whole and the parts separate in their mind. So another way we could look at it again is let's see here. Oops, I feel like I went back. My apologies. So another way we can look at it as a mixed fraction. So there's our whole plus 2 more 7ths as well. So this fraction construct is called fractions as operators. So you might not have realized it as we were doing it, but really it's the first scenario that I gave you where we had you increase or decrease the magnitude using fractions. So in this particular case, we were taking 2 fractions and we were composing a new fraction or composing a new value. So we're increasing that amount. So when we're using fractions as operators, that's like a whole other complex situation. So we have 4 basic fractional constructs, but within each, there's its own sort of path of all kinds of complex situations that we can find ourselves in. So just as a quick overview of our 4 different fraction constructs, what we're going to do for the remainder of the evening is we're going to start looking at, in particular, fractions as operators, because I think this is really important. Again, when we think proportionally, when we think relatively, we're going to have to do a lot of operations on fractions as we get into the grade 6, 7, 8, and then into high school. So we're going to use some of that, and we're going to really try to see if we can break down some of the barriers that arise when we use fractions as operators. So as we come back to this slide about what is a fraction, so when we say a fraction's a number, I think it's pretty clear that that's a pretty basic representation of what we're really talking about here. This is a really abstract concept, and I would argue that, if students build a deep conceptual and procedural understanding, we don't want to discount that, but a deep conceptual understanding of what they look like and how to work with them fluently, I think that's going to trickle across to many of the other ideas across our number, sense, and numeration strands. So here's what we're going to be doing. We've ended that previous knowledge hook question. I'm going to move to the next question, and on that screen, it is going to ask you to play a video. And in that video, we're going to have you jot down some things you notice or wonder. So we're going to have you type those things into the submission box in GameShow. At the same time, what I'm going to do is I'm actually going to grab the video link. I'll post it in the chat box just in case there's anybody who hasn't been able to get into the game show room. I know that sometimes, sometimes you've got a lot going on and maybe you weren't able to log in. So I'm going to post that video link as well so that you can access it as we go. So just give me a moment for that. You should see that link pop in. If you're in Game Show, though, you should be able to watch the video right within that window. There should be an embedded video. And once you're done watching the video, you can go ahead and hit the I'm finished button, or you can put the checkbox up on the chat box. If you don't see the video, that's not a good thing. Maybe click on the link in the chat box here. That Vimeo link should bring you to the video while you're watching in the browser. Not sure why that is. All right, it looks like maybe the video is not working in the KH screen, so that's not so great. So we might have to just resort to our chat box for this particular question. I'm not sure why that would be, but that's okay. I'm wondering if maybe I made an error on maybe a web link error when I created the question. Perfect. I'm going to repost the video just in the chat box here in case you want to watch that video. And feel free to, what we'll do is we'll just share out what you're wondering right in the chat box here. I see some great wonders going on. I see someone opening up a Kit Kat bar and notice that it's several parts combined. I wonder why you didn't eat it. Maybe I just didn't show that part. I wonder if the chocolate bar will be shared if he's going to eat the whole bar himself. I'm a pretty selfish person. Will I share it or will I eat it piece by piece? All right. Oh, we have fractional notation coming out. I should also preface this with, you know, when I do a notice and wonder in a webinar called Fractional Thinking, you know, you can definitely bet that we're probably heading in that direction. So that's definitely one reason why I really enjoy spiraling the curriculum as well, because we're not always doing like a complete unit at a time. So that's something that, you know, maybe this is a good way to sort of promote that way of thinking. Is when I come into class and we do this type of task, typically we're not sort of priming the students to think in any one way. So we're just trying to get them to think a little bit openly about you know, what they see and what they wonder. But you're definitely right. We're definitely going to go into some We're definitely going to go into some fractional thinking here. And in this particular case, I'm going to end the question. I'm going to cross my fingers on the next question that it works. I don't know if it was just a mistake on my part or not, but down on your screen, you should now see a new question. It's question 4. Hit that refresh button if it didn't work for you. But I'm going to have you watch the video there. I'll also paste it into the chat box again, just in case. But have a look, and then what I'm going to have you do when you watch that video is I want you to think what operation could be happening in that particular case. It looks like some people are locking in, so my guess is that the video is working in the KH. Can I get a confirmation that the video is showing up in the knowledge hook question? Looks like it. I see some green check marks. That's awesome. So I wonder if maybe I just did a typo in the previous question. Oh, not for Deanna or Dev. Okay, so hit that Vimeo link, but the answer options are there. Okay, so the Vimeo link's in the chat box for you. Watch that video there. And what do you think? What could be happening in this particular case? Addition, subtraction, multiplication, division, or something else in that particular question? All right, so I see 14 of 51 are in. Some people are saying they see more than one thing. Many people are seeing multiple things. So this is a pretty open question again, because you're starting with one piece. Really, depending on what you're doing to that one piece, you really could look at this in any number of ways, right? You could have the subtraction of a negative fraction. You could also have maybe multiplication or division of another fraction. So there's a lot of different ways that we can go about this. So it's a pretty open question for certain. What I'm going to do here is just show a couple scenarios before moving on and before we have you guys doing a little bit more math here. But I have a couple visuals up on the screen. Basically in that video, you started with one Kit Kat or one piece of a Kit Kat, and you ended up with 4 pieces. So as some people mentioned, you could definitely have addition. If I go ahead and look at that quarter, and I was to add an additional 3 quarters, I would end up with that whole, right? So the addition of 1 quarter and 3 quarters would get me there. As well, I could also look at this as multiplication by 4, and this representation is one that I really want to promote. This is the one I'll show in just a second, is a topic that we introduce in grade 3, but I don't think we really give enough time and effort to, because it's really useful, and it's definitely useful when we get to multiplying fractions. So if we take a look at this and think of this as 1 quarter groups of 4, right, because multiplication is groups of, and we move along here and look at this a little bit here. If I look at 1 quarter groups of 4 wholes, I have 1 quarter of each whole, and you'll notice my whole, or my other 3 quarters, are faded out there. So I'm just trying to emulate that there's 4 groups here, and we're only showing 1 quarter of each of those groups. Basically what we're doing here is an area model or an array. And I could show this. I'm using a number line here, trying to stay true to this idea of a number line, but ultimately all we're doing is just showing how this works as an area model or as an array. And if I show my whole all the way up to the number 4 horizontally, as well as my quarters all the way up to the whole on the vertical, we now can see my result of 1 whole chocolate bar, or 4 out of 4. Now we can look at this backwards and say 4 groups of 1/4, and ultimately we get the same representation. You might show it a little differently. Maybe you were to rearrange these pieces a little bit, but ultimately you end up in the same spot, right? So that's one way that we can show, or another way we can show that. So we had addition and multiplication. I'm not going to get into how we could show that with negative integers or with division, but I am going to give you another opportunity here, just in the chat window. I'm wondering if you can go ahead and do 2/3 and show what multiplying by 3/4 looks like. And when we do that, I have a knowledge hook question that I'm sending down. It's the same question, 2/3 times 3/4. I'm wondering if you can give it a shot any way you want. If you want to use the procedure, that's completely fine as well. But I'm going to encourage you to try to show it as an area model and see if you can represent what 2/3 times 3/4 looks like. And then we'll take a look at what that representation might look like. Or maybe you have another way that you'd like to show it as well. So you'll be able to upload that solution through Knowledge Hook. You'll notice I've given you 4 options in this particular case. Once you select your option, it'll give you the upload solution button. So I'll give you a little bit of think time, and I'll watch the Knowledge Hook screen to see once folks have submitted some answers. I'm loving the use of the screen here to start doing some division. This is awesome. Great job. Maybe I need to utilize the tools within the browser much more than I have in the past. All right, we've got 11 locked in. So if you're interested in sharing your solution, feel free to hit one of the solutions, even if you just pick a random one. If you're not done, that'll give you some time to finish up, and it'll still unlock that upload solution button for you so that you can still upload as we're starting to consolidate. Any and all solutions would be awesome to check out and kind of show some different representations. Feel free to get a little daring and try something a little different if maybe some of these representations are new for you. All right, I think I've seen enough come through, so I'm going to start grabbing some of these. So again, if you want to upload your solution, just hit one of those buttons, and that'll keep the upload solution button available for you. Okay, so up on the screen we've got a few of those solutions coming in. We've got some digital natives going on over here, or maybe digital immigrants that are doing quite well for themselves. We have, looks like a symbolic approach here using a multiply numerators, multiply denominator strategy, and then simplifying. Awesome stuff. So that would be kind of typical to what, what I would have learned in my, in my math experience, as well as what I taught for the majority of my career, and that alone. So that can be a struggle sometimes if that's all if that's all you know. I know for me it was very difficult to start seeing it a different way and try to build my thinking here. So here's another one. Great little solution here. So we've got this split into, it looks like we end up with, again, the 6 out of 12. So we've got our 1/2 and we have our, was it 3/4 that I saw? Awesome stuff here. And those are the overlap. And one thing I'll mention too with this representation, it can be kind of confusing even to draw out an array when you don't have the ability to use some technology, and I'll try to show you what I mean in a second when I show you what I've tried to do to represent this. But it can be very difficult because it is an abstract concept. So again, here we're using a little bit of our knowledge of fractions and symbolic representation. Awesome. Here we've got another representation. So again, using those kind of like double number lines or a horizontal and vertical number line strategy, and then showing symbolically as well. Great work. And another very similar. So very cool stuff. Awesome work here. And then I think this was the one that was uploaded by accident. And again, another awesome representation. So here's my attempt. I'm going to try to take this question and I'm going to stick to food for you, okay? So hopefully nobody just goes and binges right after this session on a bunch of candy, but it's a candy theme this evening. So I've got Jolly Ranchers, and what I meant by trying to really show what's happening, it can be very difficult because if I'm trying to, Bulk Barn, I think it's open till 9, so I understand if the room starts emptying out. Maybe you can send out a spouse or, you know, or even a son or daughter if they're old enough. But in this particular case, you'll see I'm really trying to make that 2/3 clear. I've got my 2 are I guess, you know, 100% opacity, and then we've got a faded third. So trying to show that that is empty or not there. And then as I show my 3/4, same deal. And then what you have is basically you're trying to mesh to see where the overlap occurs. So when we think about multiplying the numerators and the denominators, ultimately what you see in this array as I finish it off is my numerators are bright, and I'm showing that 2 times 3 is 6, and the denominators is actually the entirety, so the 3 times the 4, which gives you your 12. So that can be kind of tricky to do when you try to show it on paper, especially when you're shading it in. I found that can be really, really tricky for students and for adults trying to kind of keep their, you know, their thinking alive. And that's why I think we resort to the symbolic quite a bit. If we just follow the rule, it will work, but sometimes it can be very difficult to follow that train of thinking. Something else I want to show you is this idea of the value of this array. So if I pull this array aside here, this 6 out of 12, this can often be a struggle for a lot of students as well when we try to think about simplifying. And if I just kind of rearrange this a little bit, like, so I've got 6 candies out of 12. If I rearrange, that doesn't work for me. But check this out. If I rearrange it this way, you can clearly see half. Right? The other representations, you can see half as well if you start grouping, you know, by 2s, that would work there. And even over here, if you start grouping by 2s, you could see that there's 3 groups of 2, and there's also 3 groups of 2 that are unshaded. So just some different strategies for helping students simplify, I think might be, you know, might be helpful. So we can clearly see that 1/2 right there. All right, so here's going to be our last problem of the evening. We're not going to go super deep into dividing of fractions, but it is something that I think is definitely worth a look. So we're going to have you try, wow, I don't know what's happening to a little bit of my formatting here. I apologize, but 1 divided by 2/3 is what we're looking for in this particular case. I will open up the Knowledge Hook next question for you. And, oops, sorry. I'm going to skip that question. Hang on 1 second. Due to time, we're going to go right to our dividing fractions question. 1 divided by 2/3, and we'll even give you a visual of what that looks like. There's my 1, and there's my 2/3. What does that look like? So if you feel comfortable doing it symbolically, awesome. See if you can try drawing it out. It's definitely, it's definitely made me stretch my thinking when I started to try to visualize what dividing fractions really look like. Don't worry, Melissa. Division of fractions is quite cognitively pressing. It's something that I still struggle with as well. I think I have it down, but I'll tell you, sometimes if I haven't done it in a little while, boy, do I have to sit and really try to visualize it. So again, I think it's so critical that we look at what it looks like prior to introducing the symbolic representation, because for all of us that learned, the rule, invert and multiply, I mean, it works, and it's really difficult to spend the necessary time to fully understand what's going on if you already have a way to do it, right? I mean, I think the same would be true for if I was taking a class and every single time I could cram and get through, oftentimes you're not getting the full value because you're not getting a deep understanding of the concepts. You're just sort of getting through, and I think a lot of times that's what algorithms and procedures do. They get us through, but not necessarily super helpful for trying to get that conceptual understanding. So I see some solutions are in. I'm going to go ahead and end the knowledge hook question here and take a look. So again, if you want to share, just hit any of those buttons. So ready to upload my thinking, and you can upload it when you're good and ready. But let's take a look at the couple that we have, and we are closing in for the evening. So I'll only share a couple of these ones. Awesome stuff, by the way. And again, still kind of difficult to represent if you only have one image. It's really hard to kind of show that thinking. So this is where I think a tool like a screen capturing software, or Explain Everything on an iPad, or EduCreations, or whatever you choose to use, could be really beneficial for students. So I'm going to go ahead and do that. Right here, I'm going to load in a couple of those. We'll take a look at what you have. And again, if you found it challenging, don't worry. It is challenging when you haven't seen it that way before. So here's one for us. So we've got our whole, and it looks like it is chopped into thirds, and the groups are this big as it has been indicated on the page, and this is only half of that size. So 1 1/2 is the solution, which is excellent. So when we're dividing 1 by 2/3, there are 1 1/2 2/3 groups in that whole. So it's, for me, it's really critical to say what it means. So being able to actually articulate what it is we're trying to accomplish is really, really important. So if we take a look here, we've got another representation, which is great. So we're showing that whole and then that 2/3. So again, it fits 1 full time and 1 half time. What an awesome way to represent that. Again, worded really nicely, and the visual really helps with that. Here we are again. Awesome stuff. Looks great. So 2/3 fits 1 1/2 times. I really like the idea of fits, how it fits. So we're using an area model to represent this in this particular case. So if we look at another way to look at it, so if I go to, so here's my 1 divided by 2/3, and if I was to take those 2/3 and superimpose it over top, there it is 1 time, and there's that extra half time. You can see how it's overlapping, half is on and half is off. So that makes it a little bit more clear that we see that 1 1/2. Exactly. So the whole needs to be divided into 2/3 groups, which is pretty bonkers if you think about that, right? So I'm showing my 2/3, and on the left side here, my 2/3 groups are now we're looking at how many whole times 2/3 will fit. So you're really playing a juggling act with the whole, this idea of whole. And that's why when you're multiplying and dividing fractions, the whole typically changes, because you're really doing a bit of a balancing act with those pieces. And if we look at this, so there's another visual of what you have. We can do this in another way as well. So if we check it out this way, if I take my 1 divided by 2/3 and I chop my 2/3 this way and I superimpose over top, right? And I divide my 1 into thirds, so trying to keep common, because something I really want to articulate is when we divide, oftentimes we forget that division is repeated subtraction and multiplication is repeated addition. So in the most basic case, when we're introducing multiplying and dividing fractions, I'm of the belief that we want to get students to make a common denominator, just like you would with adding and subtracting, because you are taking away parts, right? You are dividing it by taking away 2/3 each time. So if you look at this and you take away 2 of those blue pieces, because 2 of those blue pieces is 2/3, I've taken it away 1 time, and I can only take half of that amount away 1 more time. So that repeated subtraction lives on. So I've got 3/3 here. If I show this a little bit more and I actually superimpose the 2/3 over top, you can see here, this is where the invert and multiply makes sense, because now I'm taking 3 times 3 and I'm getting 9 blue pieces, and I'm taking 3 times 2 and I'm getting 6 orange pieces. Okay, I'll give you a second to check that out, because invert and multiply, it's a trick, and the reason it's a trick is because it's taking place of all of this hard thinking that's going on in this visual, which again, super difficult to follow, but I think really important if we truly want a deep understanding. So in this case, I have 9 blue pieces, or 9 blue pieces in the end, and 6 orange pieces that are all the same size. So again, when we're introducing dividing, I recommend we go down to the same size pieces. That makes it a little bit more understandable, and then now we're using repeated subtraction to get there. All right. I can also now change the denominator, or change the whole a little bit, so I can go back to my thirds and superimpose, and then I notice that, wait a second, I could actually represent it like so. So I'm actually reducing, and I end up with 3 halves. All right, one more way I'll show this representation is, again, even just showing 2/3. So there's my 2, there's the thirds, and I'm going to superimpose. So there's 2/3 in the denominator, and in the numerator I have a whole, which is 3/3. All right, and if I look at it this way, there's my 2/3, and if I just see how many times that exists up here, I can see that it exists 1.5 times. So that might be another visual to explore. So if you're using cubes, you can do this as well with, you know, it doesn't have to be a whole number divided by a fraction. I can do this with any number of fractions, but unfortunately we're running out of time for the evening. So again, I'll share that Paying Attention to Fractions document. Great document that really helped peg my thinking for this session. And ultimately, as I'm teaching, again, coming back to this vision, trying to start with tasks that are contextual, visual, and concrete, sometimes ones that'll make you hungry, like we did tonight. Using the inquiry process to help us through this understanding, so trying to construct our conceptual understanding, making those connections, so lots and lots of representations, and then through the consolidation, we can start moving towards that symbolic and procedural understanding. And my hope is that if we do this, if we do more of this, and we do it consistently and do it well, it takes a long time for us to practice. You know, I'm still learning every single day on how we can try to do this a little bit better. But I think that we'll stop seeing this good at math, bad at math group, and we'll start to see that, you know what, more students feel confident in math class, and we'll have less students struggling with unfamiliar problems. So I do have some links to share with you, but you know, we'll post them, I think, in the slide deck. I don't think we really have a whole lot of time to go through them. We do have an iTunes U course. There we go. Michelle has it up in the window, so I won't spend much time on here. We also have many of these tasks, including the KitKat tasks, as well as this entire presentation will be going up on my website shortly this week. And the Give Me a Break task also has a quick link to it as well. So I just want to say thank you for joining me this evening, and I hope we'll be in touch. I'm on Twitter at MathleadPearce and on the web, tapintoteenminds.com, and I hope you all have an awesome remainder of the 2016 portion of the school year, and enjoy yourselves a very, very safe holiday, and hopefully we'll see you soon.
Okay, great. Thank you so much, Kyle. This was really a jam-packed session with tons of incredible and valuable information and lots of participation and some really fun games. I think that you really got people thinking outside the box, literally, so that's always excellent. And this was definitely one of the most interactive sessions we have ever had, I think, with some innovative way of sharing participants' response into Blackboard on the fly, pasting and uploading. So I think it worked really well, and that's something that we can remember for future sessions. So we will definitely all learn lots tonight, and we all clearly here had way too much fun. Sometimes that is something that is rarely associated with mathematics, at least if I remember correctly my years in college long ago and far, far away. I must admit that I have never seen that many smiley faces in the chat box. So that's always an excellent sign, and it was really really great to see such participation. And so I want to thank all participants. I want to thank you all for being such incredibly motivated participants and dedicated teachers, and for sharing your ideas tonight on OTF Connects. So thanks so much. So at this point, since it's already fairly late, and if you have been on a number of OTF Connect sessions recently, or if you are just eager to return to your families for the remainder of the night, I simply want to wish you all a very good night, and remind you to complete our feedback survey. When you actually quit Blackboard, you should be redirected automatically to the survey page when exiting Blackboard. But just in case, I'm going to paste the link for the feedback survey and for the certificate of participation. Here they are. For those of you who are still fairly new to OTF Connect, next, or can spare another few minutes, I would like to give you a few additional pieces of information before we conclude the session. We only have 2 sessions left this month before the end of the year and before the holidays. Both sessions are related to mathematics, but unfortunately they are both sold out already, so sorry about that. However, we have a particularly rich OTF Connects program for 2017, so please come back to our OTF website when you return from your vacation to register to our upcoming sessions, and lots of them. I'm going to quickly paste for you the links to our calendar and to our resource page, as well as to tonight's presentation. I also would like to tell you about another opportunity for those of you who are new to OTF Connects. Many of you know about it already, but if you're new to it, OTF and the Ministry of Education are providing a subsidy. If you're a qualified teacher and have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. And I'm going to paste the link in the chat box if you want to apply for that subsidy. Here it is. And as I have mentioned just previously, we would like to present you with an opportunity to give us your feedback. When you are exiting Blackboard, you will be presented with a short questionnaire. The survey only takes a few minutes, and if you could do it right after the session, that would be greatly appreciated. And you will be redirected to it automatically. And as a new feature of our webinars, we would like to offer you a small bonus as well. Once you have completed the feedback questionnaire, you will be redirected to another page allowing you to enter your name, and you will then receive a certificate of participation to this training session that you will be able to add to your professional learning resume. And please note that the certificate of participation is only available for 48 hours following this session. So if you don't have the time to do it tonight, please try to do it tomorrow. And I will provide the links again, just in case. Here are the links again to the feedback survey and to the certificate of participation. Finally, we would like to invite you to follow OTF on social media as well as on our OTF website. We invite you to check our website after the holidays to register to our upcoming 2017 sessions. I will now end the recording of this session. Please feel free to remain online if you wish to ask Kyle additional questions once the recording has ended. Otherwise, I wish you all a very good evening. Thanks again for your participation in tonight's session. Have a wonderful winter vacation, and we hope to see you back on OTF Connects after the new year. And bonne fin de soirée à tous et à toutes. Thank you.